the ratio test. What's really nice about the ratio test is there are no conditions on when you can use it, okay? But there is a drawback in that it's not always going to be helpful. It's inconclusive sometimes, okay? So let me state what this test says. If the limit as n goes to infinity of an plus 1 over an is a number L that's less than 1, then the series A sub n is absolutely convergent. So also convergent. Okay, part 2 says if the limit of the absolute value of an plus 1 over an is L, which is strictly bigger than 1. So if you get a number that's bigger than 1 for the limit, or if you get infinity for the limit, the series diverges. Okay. Here's the part that's inconclusive. If you get 1 for the limit, the test is inconclusive. If the limit an plus 1 over an equals 1, the ratio test is inconclusive. So again, there's no conditions. Your series could have positive terms, it could have negative terms, it could be alternating. There's no conditions on when you use it, but sometimes it can come up inconclusive. Okay. So hopefully if you go to use the ratio test, you won't get 1 for the limit. That's our hope. All right, let's put this test to the use. Determine if the series negative 1 to the n cubed over 3 to the n is absolutely convergent. So here you could go with the definition like we did on the first 2 problems. I take absolute values and test my new series for convergence or divergence, but you could also use the ratio test. So let's do that. An plus 1 over an. So whatever's in your series, this here, this is my an, okay? So I'm going to start, I need to start with an plus 1. So I'm going to plug in n plus 1 everywhere there's an n. The limit as n goes to infinity, the absolute value, negative 1, n plus 1, n plus 1 cubed over 3 to the n plus 1. And then I need to divide by an, which I've underlined in blue. So it's going to be messy if I write divided by. So I'm going to go ahead and flip it up and flip the fraction. Bring it up and flip the fraction. Okay? So you're going to now take and multiply by the flipped version of this. So 3 to the n, negative 1 to the n cubed. You could write it divided by, but you're going to have a fraction over a fraction, and it's going to be ugly looking. So, yeah, you just flip it. Yeah. And then what you're going to do is you're going to group up the like things in the numerator and denominator. So if I look here, I have this negative 1 to the n plus 1 in the numerator, and I have a negative 1 to the n in the denominator. I have n plus 1 cubed over n cubed, and I have 3n plus 1. So I'm just rearranging everything in the numerator and denominator so the like items are together. And from here we can simplify. So let's take negative 1 to the n plus 1 divided by negative 1 to the n. How does that simplify? Remember, when they have the same base, you subtract their powers. N plus 1 minus n. Negative 1, to the first, yep. And then I'm going to leave this n plus 1 cubed. And you can use the same trick on this last term. My base is 3, n minus n plus 1. You have an extra one in the denominator. You'll end up with the power of negative 1 there. So I have a product now. I take the absolute value. The absolute value of negative 1 is 1. So it goes away. And then everything else is positive. Okay. I can go ahead and pull this constant 1/3 all the way out to the front. And then these are both cubed, so I can combine them into the same fraction. My power in my numerator is a constant. Sorry, my exponent is constant. So this limit is going to skip over to the inside. N plus 1 over n cubed. And what's that limit inside going to be? Infinity over infinity. So you'd use L'Hopital's rule, right? It's going to be 1. You could also divide if you want, because the denominator has one term. You can split it up if you wanted to with 1 plus 1 over n. But that limit is going to be 1. So I'm getting 1/3. Was 1 cubed is 1. Is that number less than 1? Yes. So refer back to your ratio test. Part 1 tells me that the series is absolutely convergent. Okay, so let me write the conclusion down, and then we can take questions. So n equals 1 to infinity, negative 1 to the n cubed over 3 to the n is absolutely convergent. By the ratio test. Yes.
Okay, on that part where we did 3 to the n divided by 3 to the n plus 1, how did you simplify that to 1/3?
How did I simplify that? So this becomes 3 to the n minus n plus 1. You subtract their exponents. Well, I have n minus n, so they cancel, and then I'm left with 3 to the negative first.
Oh, okay.
So you're just using your rules of exponents, really, when you do that. Okay, yeah.
What about the minus 1 to the n plus 1, the minus 1 to the n?
So that one, you take negative, it's the same thing, n plus 1 minus n. So what does that simplify to? Negative 1 to the first, which is what I wrote.
Wait, did you do that to? Oh, okay. I see.
Mhm. So I'm just using my rules of exponents. If your base is the same in the numerator and denominator, you just subtract their powers. Okay? So that's how I'm getting this one as well.
Did you get the 3n over negative 1?
How did I get what?
The 3 over negative 1
So you're dividing by an. So I've got to divide by this thing I have underlined in blue here. And when you divide by a fraction, you flip it. Yeah. Okay. Other questions about it? So sometimes these limits are a little bit complicated, but what you do is exactly what I did. I just group the like things together and simplify. Okay? So I've got one more ratio test problem.